Dear students, in the last class we are discussing about projectile motion and we have left some portions that today we shall discuss those things. This is very important from examination point of view for your class examination, final examination as well as for entrance examination. In entrance examination, most of the time numericals are asked from projectile motion. We have discussed what is projectile motion, that I have already told you. The body projected into space which is being not propelled by any fuel. So, projectile motion is a motion under gravity only. We have found out the equation to trajectory of the projectile and that we have proved that the equation to the path of the projectile or the trajectory is a parabola. Path of the projectile is a parabola, that we have found out. Also, I have found out the maximum height up to which the projectile will rise. When a projectile is fired at an angle, it rises to some height, then falls to the ground and reaches the ground at some distance from the point of projection. So, what is the total maximum height up to which the projectile rises? So, that for that we have also deduced expression for greatest height. Also, we have found out the expression for time of flight. What is the meaning of time of flight? The total time taken by the projectile to reach the ground, to come to the same level from which it was projected, that is total time of flight, total time of motion, time of flight. That also we have found out expression for that. We have also found out expression for horizontal range. What is the meaning of horizontal range? When the projectile is fired at an angle, it does not come back to the ground and does not reach the ground at that point from where it was projected. It will reach the ground at some distance from the point of projection. That means, it will travel some distance along the horizontal direction. That maximum distance covered along horizontal direction is called horizontal range. So, we have also discussed all these things and I have already told you for what angle of projection the horizontal range is maximum. I have proved that when the angle of projection is 45 degree, the horizontal range is maximum. Therefore, when a projectile is fired at an angle of 45 degree, it will travel maximum horizontal distance. So, for this reason, a long jumper always tries to jump at an angle of 45 degree, so that he can jump long distance. Similarly, when you throw a javelin, the athlete always tries to throw it as 45 degree. So, it will go maximum horizontal distance. So, all these things we have discussed. Now, we shall discuss there are two possible angles of projection for the same possible angles of projection for the same horizontal range. That means, suppose you throw the projectile at an 30 degree the horizontal, it will go some horizontal distance. We will prove that there is also another possible angle. If you throw at that angle, the projectile will also reach that point. That angle will be 60 degree. If you throw the projectile at angle 40 degree with the horizontal, we will prove that if you throw the projectile at angle 50 degree with the horizontal, it will also reach the same point. So, always there are two angles of projection for the same horizontal range and the angles are complementary to each other. What is the meaning of complementary to each other? Complementary means some of the both the angles will be 90 degree. If one is 30, the other will be 60. If one is 50, the other will be 40, like that. If one is 45, the other will be also 45. So, for 45 degree, the range will be maximum. So, that I will now prove. There are two angles of projection for the same horizontal range, provided the velocity of projection remains the same. You throw at 40 degree with velocity say for example 15 meters per second. You throw it at angle of 50 degree with the velocity 15 meters per second. It will reach the same, go the same horizontal distance. But if you change the velocity, first time velocity 15 meters per second, second time velocity 20 meters per second, the range will not be same. So, there are two angles of projection, two angles of projection for the same horizontal range, for the same horizontal range, that we prove. Sometimes in the examination this comes as a question, 2 marks question or 3 marks question. Prove that there are two possible angles of projection for the same horizontal range. Either this question will carry 2 marks or 3 marks. So, what is the expression for horizontal range? Let us take horizontal range expression R, that is horizontal range. I am giving very emphasis on this projectile motion, because this projectile motion is very important from examination point of view. Either we will get long question or objective question or short questions. I will also tell you what are the possible objective questions from this projectile motion. Horizontal range, that is u square sin 2 theta by g, u square sin 2 theta by g. This is your horizontal range. U is velocity, theta is angle of projection, g is acceleration due to gravity. How to prove that there are two possible angles of projection? Now, we can write this as what? U square by g. In place of sin 2 theta, I can write sin 180 degree minus 2 theta, because sin 2 theta is same as sin 180 degree minus 2 theta. This is trigonometry. That is u square by g into sin 290 minus theta. Let 90 minus theta is equal to phi. Suppose 90 minus theta is phi. So, range becomes equal to how much? U square by g sin 2 phi, sin 2 phi. So, your horizontal range now becomes what? U horizontal range r becomes equal to what? U square sin 2 theta by g, that is equal to u square sin 2 phi by g. So, your range remains same whether the angle of projection is theta or phi. थीटा पकड़े जी होराइजनल डिस्टेंस जीव फाइ रे फाइ एंगल पकड़े से होराइजनल डिस्टेंस जीव थीटा फाइ भितर कौन रिलेशन दैट विल शो. So, you can write like this: horizontal range remains same, horizontal range remains same whether the angle of projection, is theta or phi. If you throw it at theta, it will go the same horizontal distance. If you throw it at phi, provided that if velocity of projection u remains same. If you change u, then it will be different. What is the relation between theta and phi? 90 minus theta is equal to phi, or phi plus theta is 90 degree. Phi plus theta is equal to 90 degree. Theta and phi are complementary to each other. Both the possible angles are complementary to each other. Remember it. Complementary means sum of the two angles is 90 degree. Theta angle miscellaneous 90 degree होथिबो ताले को आजिबो complementary angle. Both the possible angles are complementary to each other. Where the sum of both the angles become 180 degree, they are not complementary, they are supplementary to each other. Remember, the complementary or supplementary. So, there are always two possible angles of projection for the same horizontal range. So, these are the, when a projectile is fired at an angle, these are the possible aspects of the projectile motion. Long question can be like this: what is projectile motion? Deduce equation to the trajectory of a projectile. This is one type of question. Another type of question: what is projectile motion? Find out expressions for greatest height, time of flight, and the horizontal range of a projectile. That is another question, another type of question. And In addition to that, for what angle of projection the horizontal is maximum, prove that there are two possible angles of projection for the same horizontal range, or there may be multiple choice question. Suppose a projectile is fired at an angle 60 degree, what is the other angle of projection for which the horizontal range is same if it is thrown with the same velocity. So, immediately if it is projected at 60 degree, it will go the same horizontal distance when it is projected at an angle of 30 degree also. Both the angles are complementary to each other. So, there are multiple choice questions regarding multiple choice questions from this multiple choice questions. Simple multiple choice question, path of a projectile, either there will be fill in the blanks, it may be the fill in the blanks, it may be number of choices will be given circular, elliptical, all those things, you will choose the correct answer or write the answer. There may be variety way this question asked. So, path of the projectile, important to remember this, path of the projectile is a parabola or trajectory is a parabola. In mathematics you will read about circle, straight line, parabola, ellipse, hyperbola, etc. Two dimensional geometry. The path of the projectile, it is a motion in 2 dimensions. So, the path is a parabola. So, path of the projectile is a parabola, this is one. For what angle of projection the horizontal is maximum? For angle of projection, 45 degree, the horizontal range is maximum. Horizontal range is maximum. For angle of projection 45 degree, the horizontal range is maximum. So, for this reason, a long jumper always tries, there may be a question like this, why does the long jumper try to jump at an angle 45 degree? Because range will be maximum. A javelin when is thrown, the thrower always tries to throw it at 45 degree, because it will go the maximum horizontal distance. For angle of projection 45 degree, the horizontal is maximum. Third, two possible angles for the same horizontal range, two possible angles for the same horizontal range, both the angles are complementary. So, if one angle is 30 degree, the other angle will be 60 degree. If one angle is 20 degree, the other will be 70 degree. This may come in a multiple choice question, projectile thrown 20 degree, what is the other angle thrown, so that it will cover the same distance. Immediately mark the correct answer is 70 degree, because the angles are complementary to each other. So, like this you may get multiple choice questions for projectile motion, also short questions like this. In addition to this, there will be numericals. Now, let us discuss first. We have discussed projectile fired from the ground and upwards at an angle. Now, let us see projectile fired horizontally. Suppose you are on the top of a roof and you are throwing something horizontally. How this projectile is moved? Projectile, this is important for numerical point of view. Projectile fired horizontally. Same thing, here we will discuss the equation of the projectile. The equation of the path will also be parabola, its time of flight and all those things we shall discuss. So, let us take a projectile and fire it from a height. Suppose the height is h and fire it with the velocity u with the horizontal, like this the projectile is fired. So, in this case what will happen? The projectile will fall to the ground, but will reach the ground at some distance from the point of projection. It will travel a curved path and reach the ground like this, it will move like this. Suppose this point is O, this point is A, this point is B. Velocity of projection is O. So, this is the path. You go to the top of a building and throw something horizontally. It will move like this and reach the ground here at some distance from the foot of the building. So, what is the velocity of projection? Velocity of projection, this is the horizontal velocity of projection is u in horizontal direction, because it is projectile fired horizontally, horizontal direction. Height from which the projectile is fired. The projectile is fired. This idea is important because while bombing etc., bombing or throwing food packets etc., this theory will be applied there. Height from which the projectile is fired is h. This is the height from which the projectile is fired. So, let us find out first what equation. In this case, let us see the horizontal velocity u always remains constant. Throughout the motion, this velocity remains constant. Gradually, as the projectile moves down and down, its velocity increases in downward direction because of acceleration due to gravity. So, the vertical velocity goes on. U remains constant. The horizontal velocity remains, the horizontal velocity remains constant throughout the motion. Why? I have already told you in the last class why this velocity remains constant throughout the motion, because it is not affected by gravity, because it is not affected by g, because it is not affected by g. So, initial horizontal velocity u, but what is initial vertical velocity? Initial vertical velocity is 0. Initial vertical velocity is 0. Initially body does not have vertical velocity is 0. As the projectile falls, velocity in downward direction goes on increasing due to g. As the projectile falls, its velocity in downward direction goes on increasing due to what? Due to g, and the projectile reaches the ground with the maximum vertical velocity. So, this is the concept. Same concept in that case, in the previous case also this concept was there, in this case also same concept is there. The horizontal component of velocity always remains constant. In that case, the vertical component when the projectile is rising upwards, vertical component gradually decreasing, becoming 0 at the highest point, then increasing. Here, since the body starts falling from this point, vertical velocity goes on decreasing and becomes maximum at the point A. So, now let us find out what is the equation of path. Equation to the trajectory. Here also we will prove that this equation is equation to a parabola, trajectory of the projectile. Equation to the trajectory of the projectile. Equation to the trajectory of the projectile. How to find out equation to the trajectory of the projectile? It is a two-dimensional motion. Let us consider point P whose coordinates are x and y. Coordinates are x and y means in horizontal direction, distance covered is x, and in vertical direction the distance covered is y. So, this distance will be x, this distance will be y. If we find out a relation between x and y, that will be the equation to the trajectory. So, in order to find out the equation to the trajectory, let us consider a point P on the path of the projectile and find, suppose the coordinates of the point P are x and y, and find the relation between x and y and see what type of equation it is. Two dimensional equation, it can be equation to a straight line, it can be equation to a circle, it can be equation to an ellipse, it can be equation to a hyperbola, it can be equation to a parabola. But here projectile motion, in this case equation will be equation to a parabola, which will read in mathematics, that are two dimensional in two dimensional geometry. So, let us consider a point, let us consider a point P, let us consider a point P on the path of the projectile, on the path of the projectile. Projectile path रे गोटे पॉइंट P कंसीडर करा जाऊ, पॉइंट रा केटा कोऑर्डिनेट रहइबो, पॉइंट रा जोड़े कोऑर्डिनेट रहइबो, काहे कि दीटा कोऑर्डिनेट रहइबो, जेतु इस मोशन इन टू डायमेंशन ओनली. सपोज the coordinates, suppose the coordinates of P are x and y. परीक्षा ये लिखिले फुल मार्क रहिबो. सपोज full 7 marks are there, you will get secure on total marks provided you write like this. Suppose the coordinates of P are x and y. Now we will find out the relation between x and y. How to find out the relation between x and y? Suppose the projectile reaches the point P after t seconds from the instant of projection. Suppose the projectile reaches P after t seconds, from the instant of projection, What is the meaning of it? Suppose the projectile reaches P after t seconds from the instant, पकेबा ठू t seconds परे मनेकर P रे पहुंची. So, let us find out what is the value of x and what is the value of y. You see, same consideration in the previous case, the first projectile motion we have discussed, same consideration will be there. So, this distance x, how this distance x is covered? Distance x is covered in horizontal direction, and the distance covered in horizontal direction is due to horizontal component of horizontal velocity only, g has no role in it. So, in t seconds, horizontal distance covered in t second, the horizontal distance covered is equal to x. How this distance is covered? Which velocity is responsible for this? This distance x is covered due to u only, because you are throwing the projectile like this with the velocity u. If you do not throw it in horizontal direction, simply you drop it, then the projectile will not go like this, it will simply fall down. So, in t second horizontal distance covered is x, this distance is covered, by the velocity u only, and that u is always constant, which is always constant, u is always constant. I have already told you, because u is not affected by gravity, g does not play role in u. What will be x? Now you know the velocity is u, time is t, distance is x, and velocity is constant. So, x will be how much? So, x is equal to what? Velocity into time, and velocity is constant. So, velocity into time, that is x is equal to what? U t, one equation. Now, we find out equation for x. Now, let us come to equation for y. Y is the distance covered in vertical direction during t second, and that is u is not responsible for that. For that, g is responsible. Y is covered due to acceleration due to gravity. The vertical distance covered not in upward direction, in downward direction. The distance y is covered by what? Due to g. The distance y is covered due to g, u has no role in it. U does not play any role in travelling distance y. So, what will that? Initial vertical velocity is 0, acceleration of gravity is g. So, what is y? Y is how much? So, y is equal to what? 0 into t plus half g t square. We apply which equation here? Equation of motion. S is equal to what? U t plus what? Half a t square. This equation is also taught to in schools. S equal U t plus half a t square. So, that this will be also taught to in first year class, plus to first year class, but this is also taught in schools. So, y is equal to how distance covered is s, initial velocity u, time is t, acceleration is a. So, formula is distance covered formula is s equal u t plus half a t square. That formula will apply here. What is the distance covered? Distance is y. What is the initial vertical velocity? 0 into t plus half a. What is a? Here a is equal to g, acceleration is half g t square. So, this is half g t square. Y is equal to half g t square. This is equation 2. Now, we have found out equation s equal u t equation 1, y is equal to what? Half g t square equation 2. How do we get the equation to trajectory of the projectile? Equation to trajectory of the projectile can be obtained by eliminating t between equations 1 and 2. We want to find out a relation between x and y, which is the variable in here t is. So, let us eliminate t between equations 1 and 2, we will find out the relation between x and y. Now, x is equal to u into t equation 1, y is equal to half g t square equation 2. Equation to the trajectory of the projectile is the relation between x and y. We will find out the relation between x and y by eliminating t between equations 1 and 2. Equation to trajectory, equation to the trajectory, equation to trajectory can be obtained. Equation to trajectory can be obtained by eliminating t between equations 1 and 2. There also we are doing the same method. Equation trajectory can be obtained by eliminating t between equation 1 and 2. How to eliminate t between equation 1 and 2? एक या दुई इक्वेशन टी को बाहर करदे जो रिलेसन बाहर से एक्स वाई भितर इक्वेशन हम से ट्राजेक्टरी इक्वेशन केमी हाउ टू डू दैट फ्रॉम इक्वेशन 1 t is equal to how much x by u. Now, let us take this value of t and put it in equation 2. Putting this value of t in equation 2, putting this value of t in equation 2, we get y is equal to half g into t square x square by u square, half g x square by u square. So, your equation the trajectory of the projectile becomes what? Half g by u square into x square. G is a constant at a place, u is a constant for a particular projectile. So, half g by u square is a constant, g is a constant at a place. In the examination, you write like this. So, the evaluator will be convinced that the student has understood the things. G is a constant at a place, u is a constant for a projectile. So, your half g by u square is constant. Let half g by u square is equal to a. Suppose this constant is a, then what is the equation? Now, the equation becomes y is equal to a x square, y is equal to a x square. This is equation to trajectory of the projectile, which is equation to a parabola. This is equation to the trajectory of the projectile, which is fired horizontally. Previous trajectory was the projectile which was fired at an angle with the horizontal from the ground, but here it is fired horizontal from a height. This is equation trajectory of the projectile, which is equation to a parabola. Equation to a parabola. Which is equation to a parabola. So, this is relation y is equal to a x square. Next, at what distance the projectile will fall? We are throwing it like this in horizontal direction. So, it will travel like this and reach the ground at some distance from the point of projection. What is that distance? That distance is called horizontal range of the projectile, which in the diagram BA. Horizontal range of the projectile, horizontal range of the projectile, horizontal range of the projectile. Now, we are discussing a projectile which is fired horizontally from a height. Horizontal range of the projectile means it is the maximum horizontal distance covered by the projectile in the diagram, that is your BA. It is defined as the maximum horizontal distance covered by the projectile in the diagram it is BA. This is your friend. What is the expression for that? On which factors it depends? The only thing given to you is what? The velocity of projection is given, and from what height the projectile is thrown, and acceleration. Three things are given to you: U, H, and G. Then what is the horizontal range? How to calculate the horizontal range? First of all, let us find out how much time the projectile will take to reach the ground. What will be time? Time taken by the projectile to reach the ground. What time it will take? It will travel distance covered, height covered in downward direction. Height covered in downward direction is equal to h. How this height is covered? This height is covered by g only. So, how to calculate that? Which formula will apply? H is equal to what? 0 into t plus half g t square. H is 0 t plus half g t square. If t is the time taken, if I am writing in the bracket, if t the time taken to reach the ground, t is the time taken to reach the ground. तले पहुँचला बेलू समय नहीं मनकर टी ताले एच इज इक्वल टू कहते 0 इंटू टी प्लस हाफ जी टी स्क्वायर. सो टी स्क्वायर इज हाउ मच 2h बाई जी. सो डी टी 2h बाई जी. दिस इज द टोटल टाइम टेकन बाई द प्रोजेक्टाइल 2h by g. Time taken by the projectile, that also you can call time of flight. T is equal to 2h by g. I am sorry, 2h by g root over. This is the time. Then what will the horizontal range? Horizontal distance is covered by the velocity u, which is constant, and total time for which the projectile moves is equal to how much? 2h by g root over horizontal velocity is equal to u, total time is equal to how much? 2h by g root over. So, what is the horizontal distance? Horizontal distance covered, horizontal distance covered, horizontal distance covered is equal to velocity into what? Time. Velocity into time. When distance covered is velocity into time, we are adopting different formula. S equal to ut plus half a t square, S is equal to u into t only. In which case S will be u into t, in which case S will be ut plus half a t square. When the velocity is constant, distance covered is velocity into time. When the velocity is a variable, means acceleration is there, then that case formula will be S equal to ut plus half a t square. So, in this case velocity is constant. So, velocity to time, velocity u into time is equal to 2h by g root over. This is your horizontal distance, u into 2h by g root over. So, time taken as the ground is 2h by g root over, the horizontal distance covered is u into 2h by g root over. Another thing we can discuss also that comes in the problems, velocity of the projectile at any instant of motion. Suppose the projectile is thrown at an angle of theta with the ground, what is its velocity after t seconds? What will its velocity? Velocity of the projectile at any instant when it is projected. These are important from numerical point of view, projected at an angle theta with the horizontal. Not from theoretical point of view, but from numerical point of view, these are important. Velocity projectile at any instant where it is projected at angle theta with the horizontal. At horizontal. Velocity at any instant where it is projected at angle theta with the horizontal. Now, you are throwing a projectile like this. So, the velocity of projection is u. We have already discussed that. At this point, suppose here is a point P. Suppose the projectile reaches the point P after t seconds, then what is velocity at the point P? Velocity at any instant. Suppose the P is the point, P is u is the velocity of projection, theta is the angle of projection, P is a point. The question is, what is the velocity of projectile at the point P? Velocity of projection is equal to u, angle of projection E theta. Suppose the projectile reaches P after t seconds from the instant of projection, that is important. पकेवा ठू t seconds पर मनकर P रे पहुंची t seconds from the instant of projection, then what is the velocity at P? Velocity at the point P. Now you know, we have already discussed that u is resolved into two components. Component along this u cos theta, vertical component is u sin theta. Suppose the velocity at the point P is v. So, what is the velocity, horizontal component of velocity? What is the vertical component of velocity? Suppose here this is ux, uy. Suppose the horizontal component of velocity at P is equal to ux. Horizontal component velocity at P is equal to ux. Ux is equal to what? Ux is equal to u cos theta, because u cos theta always remains constant throughout the motion. Ux is equal to u cos theta because u cos theta remains constant throughout the motion, Now you know the horizontal component of velocity at P. At P, the horizontal component velocity is u cos theta, that is the ux. What is uy? Initial vertical component velocity u sin theta. P is the point at the projectile reaches after t seconds. So, what will be uy? How to find out? Which formula will be applied? V is equal to u plus at formula will be applied. The vertical component uy will be equal to what? U sin theta minus gt. Uy is equal to u sin theta minus gt. Which equation we are applying here? V is equal to what? U plus at. We are applying this formula. Final velocity V is equal to u plus at. Final velocity is equal to initial velocity plus acceleration into time. Here velocity uy, initial velocity u sin theta, acceleration is minus g. So, u sin theta minus gt. So, uy is equal to u sin theta minus gt, ux is equal to u cos theta. So, what is the resultant velocity? The resultant velocity will be, how to find out resultant velocity? S component is known, y component is known. So, how to find out resultant velocity? Ux square plus uy square root over, ux square plus uy square root over, that is equal to what? U cos theta whole square plus u sin theta minus gt whole square, the root over. This will be resultant velocity. That will be velocity of the projectile at any standard magnitude, that is equal to u square cos square theta. This is a minus b whole square, u square sin square theta, a square plus b square minus 2ab plus g square t square minus 2u sin theta gt root over u square cos square theta plus u square sin square theta is u square plus g square t square minus 2u gt sin theta root over resultant velocity, magnitude. resultant velocity, magnitude after what? After time t, this is velocity after time t. After time t, this will be magnitude of velocity. What will be direction of this velocity? Suppose suppose after time t, it is inclined at an angle theta. Suppose this angle is, say for example, this angle is phi. Suppose this angle is phi. So, what is phi? Suppose the velocity, resultant velocity after t seconds, suppose the resultant velocity at p is inclined at an angle phi with the horizontal, because you know the velocity is a vector quantity. So, in the examination, suppose in a problem you are asked to find out the velocity. So, you have to find out magnitude as well as the direction. Suppose the resultant velocity at p is inclined at an phi the horizon. Manekar ei jagare se horizontal sahita phi kono kariki achi. Tal phi kemti, how to find out phi? Tan phi. What will be tan phi? Look at the diagram. Uy by what? Ux, Uy by Ux. Tan phi will be Uy by Ux. Uy is how much? U sin theta minus gt by what? By u cos theta. U sin theta minus gt by u cos theta. So, your phi is how much? Phi is equal to u sin theta minus gt by u cos theta. Tan inverse phi is equal to tan inverse u sin theta minus gt. This inverse function will read in trigonometry, tan inverse u sin theta minus gt by u cos theta. So, we find out what? Uy by uy by uy. So, we find out the magnitude of the resultant velocity, this is the magnitude, this is the direction. So, if the examination is asked about the value of u is given to you here, angular position is given to you, after t seconds some time you are asked to find out the velocity, you can find the velocity of magnitude of velocity and also direction of velocity. In projectile, from projectile motion usually numericals come. I am just solving one numerical based on this. Suppose a numerical is given, a bomb is dropped from an aeroplane from a height of 490 meters above the ground. A bomb is dropped from an aeroplane from a height of 490 meters above the ground, and the plane is flying, plane is moving with a velocity 360 kilometer per hour, 360 kilometer per hour, 360 kilometer per hour. By what distance? By what distance the bomb will miss the target? By what distance the bomb will miss the target? A bomb is dropped from an airplane from a height of 490 meters from the ground, and the plane is moving with a velocity of 360 km per hour. By what distance the bomb will miss the target? Like this. This type of question can be asked in a different way. Let us first solve it. It is at a height of how much? 490 meters, and it is moving the velocity of what? 360 kilometer per hour. 360 kilometer per hour. So, how the bomb will move? The bomb will move like this. So, distance through which the bomb will miss the target is how much? O, A, B, like this. The bomb will move like this, 360 kilometer per hour. So, we have to calculate this distance, because if the target is here, bomb is allowed to fall here, then it will not reach the point B, reach the point A. So, this is the distance to which the bomb will miss the target. So, in order to hit the target, the bomb is to be dropped from a distance, that will calculate. So, the question, if it is dropped from just on the above the target, it will miss the target. In order to hit the target, it must be dropped from the distance, from a distance. So, let us calculate that distance. You see, velocity of the plane is given in kilometer per hour, height is given in meters. So, the velocity must be converted first to meter per second. What is the velocity of the plane? Velocity of the aeroplane 360 kilometer per hour. So, you have to first convert it to meter, that is the most vital part. I have already told you, in order to solve a problem, we are solving a problem, first of all you must find out what is the correct formula to be used. Second, the data must be in the same system of unit, एका सिस्टम रे रहिबे ये मीटर अछि माने से मीटर रहबो किलोमीटर रहले हो नै 360 किलोमीटर पर आवर 360 किलोमीटर मीटर 1000 hour must be converted into seconds 60 into 60 so meter per second. So, this becomes how much you see 60 into, so this becomes 100 meters per second. So, velocity of the aeroplane is 100 meters per second. With this velocity moving, what is the height through which the bomb will come? 490 meters. So, that will be 490 meters, 490 will be 0 into t plus half g t square. Formula is what? Which formula we are applying? S is equal to u t plus half a t square. This formula you are applying here. U is equal to the vertical component of velocity 0 and a is equal to your acceleration to gravity. So, t square is equal to how much? 2 into 490 by g. You can put 2 into 490 that 980 by g is 9.8. So, this becomes how much? 100. So, t is equal to how much? 10 seconds. So, the bomb will take 10 seconds to reach the ground. It will take 10 seconds to reach the ground. So, during this 10 seconds, how much distance will cover? Horizontal distance covered, horizontal distance covered, horizontal distance covered by is equal to B A, that is equal to what? Velocity 100 time 10. So, this is 1000 meters. Horizontal distance covered is. So, in order to hit the target, the bomb must be dropped from a distance of 1000 meters, or if it is dropped from the just on the top of the target, it will miss by a distance of 1000 meters. So, it will, if the question is from what distance the bomb will drop, so that to hit the target, it will be dropped from a distance of 1000 meters, or if it dropped directly on the spot, then it will miss the target by a distance of 1000 meters. So, this type of question may come in the examination. It is very important because, so to hit the target, the pilot must drop it from a distance, and how much distance, that is calculated by the pilot there, calculated by computer. So, what is the height, what is the velocity of the plane, all those things are calculated there. So, he has to drop it accordingly. Like this, you may get problems in the examination. So, this is all about projectile motion. In the next class, we shall discuss about circular motion.